We've looked at what integrals are conceptually, but now I'm just going to write out the basic integral rules so that you have it as a list. These are just the reverse of the derivative rules that we wrote before. So we have the power rule. This is saying the integral of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c. In this case, n cannot be equal to -1 because then we'd have a derivative. Then here we'd be dividing by 0. So if you have here x to the -1, the power rule does not apply. For the trig rules, we have the integral of sine of x dx equals negative cos x plus c. The integral of sec squared x dx equals tan x plus c. And the integral of cos x dx is equal to sine x plus c. For the log and exponent rules, we have the integral of e to the x dx equals e to the x plus c, and the integral of natural log of x, the integral of 1 over x dx is equal to the natural log absolute value of x plus c. Note that here this x to the -1 was equal to 1 over x, and now we have the result for that particular integral. And now let's go over integration by substitution. This is best used when you see terms that are derivatives of other terms in your equation. So by that I mean, I'll just write this in for you. Best used when you see terms that are derivatives of other terms. So for example, if you had, the question was the integral of x cubed plus 5 to the power of 100 times 3x squared dx. So here you can see very easily that you have an x cubed here and you have a 3x squared. So this is the derivative of this. So that's a hint that integration by substitution is probably a good technique in this case. So what you do is you choose a new variable, u. Usually this is the innermost expression or inside term of a composite of functions. So in this case, we're going to use x cubed plus 5. So here we'll say u is equal to x cubed plus 5. Now compute the derivative of u. So here we're integrating with respect to dx. So here, compute du. Now du is equal to the derivative of u with respect to dx times dx. So in our example here, du is equal to the derivative with respect to dx of u, which is x cubed plus 5 times dx. So then du is equal to 3x squared. The 5 becomes 0. So du is equal to 3x squared times dx. So now we have a u term and a du term. And we're going to rewrite this equation using only u values. So here we had x cubed plus 5 to the power of 100 times 3x squared dx. This is u to the 100. This is here, du is equal to 3x squared dx. So this whole term is du. So now our integral has become the integral of u to the 100 to the power of 100 times du. Now evaluate this integral. It's very easy. Now we just have reverse power rule. So the integral of u to 100 du is equal to u to the 101 over 101 plus c. Now you just replace each occurrence of u with the expression in x, because we really want to know the integral of the original equation. So then here, replace So then u to the power of 101 plus c is equal to x cubed plus 5 to the power of 100 divided by 101 plus c. Another example of integration by substitution would be the integral of x cos of x squared dx. Notice that the derivative of x squared is x. But the derivative d over dx of x squared is equal to 2x. And here we only have 1x. So I'm just going to rewrite this so that it matches this exactly. So this expression could also be written as 1/2 the integral of 2x cos of x squared dx. So now I can always just keep this constant outside, multiply it at the end, and that's made these calculations a little bit easier. So for my first step, I'm going to say let u equal x squared. Then du is equal to d over dx of u times dx. So here, this dx, technically dx over dx is equal to 1. So all we've done is rearrange this so that we can manipulate it in a way that benefits us. So then this is equal to d over dx of x squared dx, which is equal to 2x dx. This was step 2. Now we rewrite equation using u. So then we have 1/2 cos of x squared dx becomes 1/2 of cos of u du. And this is just one of our basic integrals. So we evaluate. If we just evaluate this, we get 1/2 sine of u plus c. Replace the variables. We have 1/2 sine of x squared plus c. In these problems, usually the trickiest part is noticing that substitution will help you and then knowing what to use as your u value. Another technique that helps you evaluate some of those trickier integrals is called integration by parts. The formula for this is if you have an integral of the form u dv, you can rewrite it in the form uv minus the integral of v du. So the example that we're going to use for this one is the integral of x sine of x dx. In this case, we can't use any of our basic integrals because it's too complicated. And we also can't use substitution because there's nothing here that looks like the derivative of something else. So we need another technique. So for this one, you actually choose something that you want to take the derivative of, and you choose something that you want to take the integral of. So in this case, if I take the derivative of x, it's just going to become dx, and it's very simple. And the integral of sine x is going to be minus cos x, so it stays pretty simple as well. So I'm going to set u equal to x. So that means I'm saying the u from this equation, I'm calling it the x here. From here, if I take the derivative of both of these, I'll have du equals dx. And then I'll set dv here as this second part, sine of x dx. So I'll say dv is equal to sine of x dx. If I take the integral of this on both sides, the integral of dv will just be v, is equal to the integral of sine of x dx, which is equal to minus cos of x plus c. In this case, I'm going to drop the c just for now and add it again at the end, just because it's going to get in my way, and I know I can just add one again and at the end, and it's just an arbitrary constant. So now what we've done is we've come up for the u value, we've defined it as x, and this as sine x dx. Now we can just rewrite it in this form. So then plug it in. So now u is x. Actually, I'll write it maybe, I'll do this, uv minus the integral of v du. So the u is x. Our v is minus cos x. And then we have minus the integral of v, which is this, minus cos x, times du, which is dx. Now to evaluate this integral, we're only doing the integral of minus cos x, which is really simple. So then we have this is equal to, oh, this was multiplied. So then we have minus x cos of x. The integral of minus cos x will be minus sine x, and we already have a negative, so here this will become plus sine of x, and I'm going to bring this c down here, plus c.